Hello, my name is Camila Pagán, and I am part of Challenge 2014. And this is the video assignment for Math 1000. Question number 1. And question number 1 states, to write the limit of 2x minus 5 when x tends to 4 when it equals 3. And so, in order to solve this, we need to use epsilon delta. And the formal definition of epsilon delta states that the limit of f of x equals L as x tends to A. That means that for any epsilon greater than 0, we can find some delta greater than 0 so that zero is smaller than the absolute value of x minus a when it's smaller than delta, which is also rewritten as the absolute value of function x minus L less than epsilon. So this is the formal definition of limits, which is using epsilon delta. Okay, and so in order to answer this question, we need to find the variables. First of all, in order to insert them in this definition, the first variable would be the function, which is given by 2x minus 3, because it's inside the parentheses. That's the name of the function. So 2x minus 5 is the function. And so L is the value of the limit. So we have 3. L equals 3. And A, which is the value in which x approaches, is 4. And now we insert into the equation, which we will use this definition first, which means that the absolute value of f of x minus L is less than epsilon. And so we solve by inserting the values. F of x would be 2x minus 5 minus L, which is 3, minus 3 less than epsilon. We subtract. We take the largest, the greatest common value, which is 2. And finally, we divide. And this is the original value, which according to the formula is what you want to reach. This original value is this part of the equation, but with the a inserted. And since we have here that a is 4, x minus 4 is less than delta. So we have that x minus 4 is less than epsilon over 2, which is the same as delta. But in order to be able to create this kind of limit, we need to be able to prove it. And so, in order to prove, we have to use the inverse of this equation in order to find it, to be able to show that it's the same thing coming up from down, then down to up. Okay, so proof. We can prove that if the absolute value of x minus 4 is less than epsilon over 2, then we can, the 2, we take it outside of the equation. 2x minus 4 epsilon over 2. And then we multiply. Oh, oops, this isn't going because we already divided. And then, after this, we have to make it look like the original function. In order to make 8 is the same thing as 5 minus 3. So we separate. 2x minus 5 minus 3 greater than epsilon. And so, here we have our original function as we first wrote it when we inserted the values here. Okay? So, and finally, in order to finish an epsilon delta problem, we need to write the formal definition for this equation. So, if 0 is greater than the absolute value of x minus 4 greater than e epsilon over 2, then f of x minus L, well, its absolute value, will be equal to 2x minus 8, which is equal to 2x minus 4, which is also equal to x minus 4, the absolute value, when, which is greater than delta, which is then equal to epsilon squared. And we know this is true. Wait, closer. And we know that this value is true because this right here is less than epsilon, then delta. And if it is less than delta, then it will satisfy the original definition, which states that 0 has to be, that x of a has to be less than delta. X of 4 is less than delta, so epsilon over 2 will be our final answer. Thank you for watching. Goodbye.